Yeah, that would have been an issue. So, um, is the 2022 paper B right? The paper that we're doing? I think so. So let me go to code blocks. Yeah, I think it's this one over here. Yes, the render. Mm. Yeah. Yeah, these days when I sleep, I sleep. It's like I'm dead or something. I just sleep. I don't. Yeah, it's very scary. That means I can even be kidnapped most.
Hmm. So you're a heavy sleep almost.
Not really. I get I started drinking things like okra water, whatever. And that sort of like regulates, I don't know, it just came with that feature. I don't know. I just started sleeping more deeply.
Uh,
Yeah, I started getting deep sleep. It was the okra, well, because when I hadn't been drinking it, I was struggling to sleep.
uh, Maybe I
Yeah,
should
so
start drinking.
yeah, just start to drink it, but just be careful that you're gonna sleep deep. They think you're dead. They're like, "Hey, Misha, where?" Person is gone.
Yeah. And I'm a
Yeah,
deep sleeper already, so I don't know anymore.
yeah, which is good because you can get some proper. Yeah, I agree. You don't have to drink the okra every day. You just drink it only those days when you, and it also has like uh, cleansing properties. It's gonna cleanse your stomach. So
Mm.
yeah, so it's gonna help with your digestion or whatever, removing all toxins from your body. So it's very good.
Okay.
Mm,
I don't like the
mm.
texture. I've always seen how slimy it is. I don't like slimy things.
You don't like what?
Slimy things.
Oh, you don't. You can get a blender, and then uh take that okra water and then put it into the blender and then put some fruits in the blender, then you blend.
I
I'm
don't
sure
like
that
smoothies.
my sister, it's not about you liking it, it's about you get, helping
I have a
yourself.
texture problem. Like I don't like smushy things and stuff. So yeah,
Okay, once off,
cannot
you
be.
must try it once off. As long as it doesn't like if as long as you don't have that sort of reaction whereby you end like you actually like literally vomit if you start getting it when you come into contact with slimy things. If it that doesn't happen to you, then I guess you should be safe.
All right.
And so class constants. I forgot to declare my class constants. So class constants, why do we need class constants? Because remember, we're going to have this guy over here, the parameterless construct, meaning that we're not going to take in any values from the user. This means that we must come up with our own imaginary values. And what are the values that we typically need? We need three. We need the size, meaning the rows, the columns, and the default pixel. And then in our case, yeah, okay, in our case, yeah, so this is going to be a bit tricky. So let's do it since we have an array inside the regular structure, but let's do it. So you're gonna say static, right? Static meaning that they are shared.
Mm-hmm.
Instead of each object having its own copy, we share. So it's like for example, you and your girl best friend, right? You see a cute what is a cute jacket, right? Instead of imagine you and your friend and your best friend, you have the same body size, right? Like same things that you wear can fit your best friend. So when you go there to shop, go to wherever you're going to do shopping, then you find that jacket. Instead of each person getting their own jacket, you can instead, let's say the jacket is 800. You can instead buy one jacket and spend 800, right? And then you share. If today you wanna go to a date, whatever, you be like, yo, show me, can you please give me the jacket? I'm going, there's this guy, I wanna go on a date, blah blah. Then Chomi gives you the jacket, right? And then next week or whatever, Chomi has an important event, right? And then she says, Chomi, I also wanna go somewhere. Can you lend me the jacket? So it's sort of like that. You're sharing that thing. So that means you guys would have saved 800. That 800 that you have saved, let's say you just decide to go 50-50. She gives you 400, she takes 400. Then you go spend on your own things with that 400. So computers sort of like use that strategy in order to avoid using too much memory. So in terms of computers, since you guys will be saving money, the computer will be saving memory or space. So that's why we use static. And then I want to create a constant, just like a constant in maths, which is pi or whatever constant that's the even in physics, and I'm sure you did science, there's constants that are there, right? So that const keyword says that let's define a constant or a value that doesn't change. And then and then followed by the type of that constant. I'll use an unsigned short. Remember, you don't have to. You can just say it's an int and then done. Say it's an unsigned short because I'm trying to save space. So unsigned short default. And then since it's a constant, right, there's this rule that you need to name your constant in capital letters, right? And then each word should be separated or divided by an underscore. So if I have this word, these two words, default and rows, you see that these are two words. It becomes hard to read that word, right? So what you do is you separate. So you put an underscore in between the words. So you see it becomes easier to read. And then you assign that constant a value because what the rule is that you're saying you want to create a constant. So obviously the constant needs to have a value. For example, the constant pi has the value 3.14. So we need to initialize the value the same time we are creating the constant because it's called a constant. After this, it cannot be changed because it's a constant. So I'm going to say, let's make an image 800 by 800. Static const unsigned short default calls is equals to 800. And then last but not least, usually pixel. So you use const, right? The trick to know which one to use, whether you use const expression or just const keyword. You use const if you have an integral value on the right side of the equal sign. If it's one value, in this case, the computer views that one value as an integer. If it's an integer on the right-hand side, then you can use the const keyword because const just stands for a single value. But then when you're initializing something like a struct, it doesn't need to have multiple values. It does, you see? There's red, green, blue, and that. So there's more than one value. So that's now called a const expression. Just like a mathematical expression, right? Remember, the mathematical expression has multiple values in it, right? So
Okay.
const expression, what, and then followed by the data type. The data type is a UJ pixel, and then followed by the name, default underscore pixel, is equals to, since we're initializing multiple values, you use curly braces like that. And then those curly braces, what you need to do is you need to pass these values in that exact order. So I need to pass in the red value, and then I put a comma, and then I pass in the green value, then I put another comma, and then I pass the blue, and then I put another comma, and then I pass the shorts. There's seeds, I mean. So let's say, should I say black or whatever? Let's make it white. Let's make it a white background if the user doesn't give us a color. So 255, 255, 255, right, comma. And then remember what I said, use curly braces to initialize multiple values, right? If you look at the fourth one, isn't it multiple values? It's an array of 5 values. So I need to put another curly brace within this curly brace. So I'm gonna put another curly brace there. And each curly brace is accompanied by, or each opening curly brace is accompanied by its corresponding closing curly brace. So within here, I can put in the values. Remember, there's 5 of them. So I'll just come up with any value. So me, I'll just initialize it to 0. So 0 is everywhere, like this. I'll just initialize it like that. Just put multiple values there, zeros. And then seems like this guy is gonna complain. Let me see. I did get the same error there. What? Let me see what this guy is. Oh, I forgot the semicolon. I thought maybe something was wrong there. So fine. UJ is not raw method, but let's not worry about that. So there's the constants. And then just before we continue, right? If you notice something, we are missing the 2 functions to read and write to a file. So let me just put them here so that I just finish everything. And I did do this paper and it came out exactly like this. You see that if you follow every single instruction, your output will be exactly the way they showed you here. So yeah, so add a member function to the UJ class that will load information from a text file. The function must be called by the UJ image default constructor. These people are they're very expressive, right? They tell you that it needs to do this, then do that. So file handling methods, right? So file handling methods. So whenever you do file handling, right, it'll always not return anything. If you see here, you see that we are not storing this returned value anyway. So that means it actually doesn't return anything. So if there's no equal sign like this, let's say x, that means that function doesn't return anything. So they expect you to have that to get to that conclusion. So I'm gonna say void load from txt, right? To load from a text file. And I need to pass in the name of the file, which is a string. And the string is an object, it's a class. So I need to include its header file. So string hash include string. Then I scroll down and then I need to specify which namespace the string comes from. So standard and then colon string, and then this will be the file name, right? And then since they didn't call here, because they told you to call the read method within the construct, so that means that I can give it any name. You see that they didn't call it here. If they had called it here, then you're supposed to use that specific name that they assume you have used. Just like in this case here. To save to binary file, they expect you to call it save to that, like this, exactly like this. So I'm gonna copy that text there and then go to my UJ image and then say void save to that and then take in a string file name, right? So there's the 2 files. And then we were on the verge of doing the composition, right, for this draw thing. So let's do the composition. I don't like how they structured this thing. Information is everywhere. You have to scroll up and down, go there, then go there. Yeah, it's not very demure. So UJ image class has a renderer. Be very careful. Renderer. That they didn't say, which is true that the child classes are also renderers, but they told you it has a renderer. They didn't say it has a stochastic renderer or a continuous renderer. They didn't say that it has those renderers. They just said it has a renderer, meaning that it is an instance of the base class. So be very careful. So let's declare it here. So renderer, right, underscore renderer. And remember what I said, if they tell you that UJ image manages its life cycle, that means there's a life cycle dependency, meaning that you have to make it a pointer. That means composition, right? One cannot exist without the other. That's composition. So you have to use a pointer. If they don't tell you or they tell you that UJ image does not manage its life cycle, then you can omit that pointer. So yeah, that's pretty much what you need there. And then remember they said UJ image delegates its own draw method. So which implements the draw blah 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 non-value. And then UJ image, right, delegates its own draw method to the contain render. So I need to create my own draw method inside UJ image. So I'm going to say void draw. Most of the time, it's just going to be an empty function with no parameters, right? Most of the time, yeah, it's just going to be like that. So you create that function, draw, and then done. I think now the class is 100% complete. Yeah, it's 100% complete now. So what I need to do is this renderer over here, right? Okay, this is quite an interesting thing, but let me leave it. Um, this renderer here, right? UJ image will complain that it doesn't know what renderer is because you see that I didn't include its header file here. So technically, there's no such thing as a renderer according to UJ image. So it's going to complain. What do we need to how we can fix that? We can to avoid this thing called circular dependency issue, right? To re-include a header files within a class and then re-include them in another class. What we can do is in all of our header files where we did composition or aggregation, we do forward declaration. So for example, in the UJ image header file, didn't I do composition? Yes, I did. So I'll only do forward declaration. So forward declaration is basically you creating an empty class using that name because it will say, I don't know what render is. So what this does, it tells UJ image that, listen, renderer is some type. It's a class. But for now, all you need to know is just it's a class. You don't need to know about methods or whatever. And which is good because in your header file, you don't implement, right? Did you call anything from renderer class? No, you didn't. So there's no need for you to include the header file here. And then within your CPP file, that's when you call the header file. Since you're gonna call methods from this header file, right? Remember, you're gonna delegate and call this draw method. So it needs to have the full implementation of that class. So what I'm going to do is I'm going to copy everything here because now it's time to implement, right? And then before I forget, like I said, we need to include the render as header file inside ujimage.cpp. So hash include uh, render.h, and then I paste all of my methods there. And then when you go to the implementation file, right, in the textbook, it tells you that you must remove parent keyword, override keyword, virtual keywords. You must remove those keywords. They're not supposed to be in the implementation file, or else your code is going to crash. So I hope you take the author's advice. And then you remove the semicolon, you put curly braces because you want to provide the actual implementation for that function. And I realized that I forgot something very important. Your helper methods. Remember that we're going to overload the assignment operator, meaning that there's code that we're going to put there which will be from the constructor, which will also be from the copy constructor, which will also be from the what is this from what from the destructor. So we're just going to repeat ourselves, right? You see that you repeat ourselves, and we don't like repeating ourselves because we are programmers. We are lazy. Programmers are lazy. That's the most common code you get out there. So we need to be lazy and not repeat ourselves. And then these are just constants. I'll use them there. So I'll just delete them. And then put this there. Uh, I I hope these funds come through. Hey, I need to get a new laptop. Hey, and then do that. And then all I'm just doing right now is I'm just telling C++ that don't be shocked and ask me where this function is coming from. It's part of UJ image. That's what I'm doing right now. I'm attaching this code that I'm about to write to that specific method from that specific class called UJ image. If you don't do that, it'll crash when you try to use UJ image from another place because it'll say you haven't implemented the methods. That's how the computer is. So remember, I need helper methods. And remember when I was explaining, what did I say? I said that the helper method, the reason why we need that helper method, right, is because we're going to take some code, the code from this constructor, parameterized or whatever constructor it is, and then we're going to take some code for the code from the copy constructor, and then take the code from the destructor. We're going to use that same code within the assignment operator. So since I am going to make use of three of those things, I need to create helper methods. To make my life easier, I'm going to call the helper methods based on the code that it will contain. So the first helper method will contain code from my constructor. So I'm going to call it constructor. Some call it allocate memory or doesn't matter. Me, I like to make things simple. So I'm going to call it constructor. And then you always, for the constructor, right? You always go to the constructor with the most parameters. You see, the third one is the one with the most. It is 3. So I'm going to take that one and take those exact same parameters, put them there. And then void, I'm going to need the copy constructor helper method. Copy constructor helper method, which is, it's called a copy constructor. So that means it's going to be the same as a copy constructor. So I take that same parameter too. Then I go down here and then I pass it in there. And then the last one is the destructor, which is this one over here. You see that the destructor takes in no parameters. Hence, they need to be the same. And then I'm going to take the helper methods, I'm going to put them inside the implementation file. And then I'm typically going to put them just right before the destructor, right? And then I'm going to specify that these methods are part of UJ image. So I'm going to put this keyword UJ image colon colon right next to the methods names. That's how you tell UJ image that, okay, listen, this is part of UJ image. Yeah, so this will be, I'm just going to put a comment here. This will be my helper methods, right? And then I'm going to do this so that it can fit on the screen since I have a small laptop. So obj right hand side, that's what I'll call it. So let's start with the destructor, right? So the destructor code, you're always going to okay, let me not start with the destructor. So let me start with the allocation because the allocation destructor is sort of like the inverse of the constructor. So it's sort of like undoing what we did in the constructor. So now I can give my parameters names, right? Those variables, because I want to access their values since I'm now in the implementation file. So let me initialize the rows and columns. So underscore rows is equals to those rows, underscore calls is equals to those columns from the user. That's why I use an underscore, because if I don't use an underscore, you see what the problem will be. It'll be like, hmm, interesting. You're saying rows is equals to rows. Which rows is which rows? Is this rows on the left hand side the one that you're getting from the user, or this rows on the left hand side is the one inside of your class? It gets confused. So that's why we just use underscores when we declare our variables so that we put away that confusion. So underscore rows underscore calls is equals to that, and then this pixel over here will be the pixel that will be set in every single row and column. So I will set the pixel once I've allocated memory. So let me allocate my array, right? Pixels array, I'm gonna say it's equals to new UJ pixel pointer, right? Because remember this underscore pixels array, 2D array, it's of type UJ pixel pointer pointer, right? So that's why I'm going to say new UJ pixel pointer pointer. But then to specify the size for each, what is this? To specify the size for each dimension or for each pointer, you replace each pointer with a set of square brackets. So we start with the outermost pointer, right? Because that's the closest one. And then I'm going to replace that with the square brackets, and then I specify the size of that dimension. So underscore rows. So it's going to be of size underscore rows. And then I go through each row because now I have allocated that dimension to be of size rows. So now that means there's a dimension of that size of rows. So now I go through every single row within that dimension. So answer in short, R is equals to 0. R is less than underscore rows, R plus plus. Which is this okay. Let's fix this, right? Before we continue, I agree this is what you're used to, right? I agree you're used to this, right? Let me see. Um, this becomes a bit tricky, right? Um, yeah, it becomes a bit tricky, but it's fine. We'll change where we need to change because they told you that the rows and columns, you're not getting them from the user, you're getting them from the file. So underscore pixels array at every single row. You see now, remember I've allocated it to be that size of rows. So now I can use it. Now I just pass R, which starts from 0 because arrays are 0 index. It starts counting from 0. So it starts gets the first row, and then at every single row, I want to set it to be another. I want to initialize the other dimension. Because remember, a 2D array is basically a one-dimensional array where in that one-dimensional array, at every single index or at every single position is equals to another dimension. So hence I'm doing it this way because that's the formula. So here I'm instantiating a new UJ pixel, and you see I can't use those two pointers again because remember I've already allocated for the first pointer, so I can omit that. And then now I'm left with this one pointer now. Remember what I said, to allocate, you replace the pointer with a set of square brackets. So I replaced that pointer. And then now, since this previous one I set it to underscore rows, this one I'll set it to underscore columns. So underscore columns. That's what I'll set it to. And then once I have set everything, now I can go through every single coordinate, right? Remember, in our case, our coordinate will be RC. We'll use R and C to to get to get the coordinate for that specific pixel. So underscore pixels RC at that coordinate RC, set it to what? Remember, our constructor takes in a pixel, set it to this pixel. So I'm going to say is equals to pixel. And then I'm done instantiating. Obviously, we're not really done because why? It's a requirement for UJ image to manage this object's life cycle. So we need to instantiate that object. So let me do this. Okay, yeah, I've already declared this. Okay, we'll do that last because if I do it now, that means I need to create all the child classes, of which it's a lot of time to do that. So let's just continue. So I've allocated memory. Yeah, this is how you're going to allocate memory. It's always gonna be that, like in this case, especially since you guys are doing 2D arrays, you're always gonna allocate it this way. And then copy constructor, right? A copy constructor, the reason why you might ask yourself, why do we have an assignment operator and a copy constructor, which basically do the exact same thing? Well, we have those because one does better job than the other. A copy constructor, it's like, for example, you have a glass, right, and you bought Coca-Cola, and the Coca-Cola is 1 liter, right, or 2 liters, whatever that quantity. Obviously, the glass is smaller than that bottle of Coca-Cola, right? T- Let's say, for example, that bottle, that bottle, that glass is like 350 milliliters, right? Which is obviously smaller than the 2 liter or the 1 liter. That means you can't possibly pour every ounce or every liter of every drop of that Coca-Cola within that glass. You can't pour all of it, right? So with that being said, that means it's going to do what it call a shallow copy, meaning it's going to copy some and leave some in the bottle. Then the assignment operator, its job is it does what we call a deep copy, meaning that it will say, okay, it will compare the sizes of the two containers. It will say, oh, this is a glass, this is obviously small. Let me delete that, let me throw it away. Let me go get a container that's also 2 liters. Then it pours the 2 liter because now they're of the same size. So it's fine. We need that copy constructor so that we get exposed to so that we know the differences between the shallow and the deep copy. So from my object, I want to get the rows. So obj right hand side dot underscore rows, right? Those private rows. And then I go through, so then I go through the columns. So unsigned short C is less than obj right hand side dot underscore calls C plus plus. And then now I've gone through all my rows X's and my columns X's. Then I can get that specific coordinate now by indexing. So to copy, it's simple. I want to copy into my array, which is underscore pixels RC. And then the right-hand side is the value that I'm copying from, which is what this object over here, obj right-hand side. So you're going to say obj right-hand side dot underscore pixels RC. So what this means, it means go to that object that you're taking in here and copy the pixels from there and put it into my pixels array. That's simple. Pretty much the only thing you need to do. That's that. And I know some people be like, well, why didn't you make sure that they're of the same size? Well, then it wouldn't be a shallow copy. Remember, copy constructor does a shallow copy. It doesn't check the size. So I would leave it like this. It doesn't check any size or check anything. And then the last one is the destructor. So since we allocated, look at how we allocated. Didn't we allocate every single row to a number of columns? Yes, we did. So we need to go through all the rows and then delete that columns first before we can delete the rows. So unsigned short r is equals to 0. R is less than underscore rows r plus plus. And then we delete, right? How do we delete? You just type the delete keyword, which is straightforward. So delete underscore pixels RC. Remember, we used to say RC, right? Now to delete, you just leave that second dimension empty, which basically signifies that you're emptying it out. So you leave that second dimension empty, right? Like this. This one needs to be empty. But then the syntax in C++, it requires you to move that square brackets to this place, which is after that delete keyword. That's just C++ syntax. So I'm gonna move that to here, and then you see it now, which kind of makes sense because it says delete what this at what that row. Because why? We allocated at every single row at that row a new pixel of size columns, so a new dimension. So what C++ does, it says the syntax that it says delete this dimension, empty it out at a specific row. So now we've deleted the columns dimension, right? So here you're deleting delete columns dimension. And then now we delete the rows. So delete rows dimension. So delete underscore. So which one are we emptying out? The rows. So I just leave it empty like this to denote that I'm emptying it out. But then remember, C++ syntax requires you to put the square brackets after the delete keyword. And then something that I see a lot of students make a mistake of, it's forgetting that there's this thing called setting it to null point, right? Draw.io. So let me show you what it means when you use the new keyword. There's this thing called a stack and a heap. For the sake of time, I do not have the time to explain it. I think I did explain it in one of the videos. You would have to go there because
Yeah, I saw it on YouTube.
because if I explain it, that will take a long time. But yeah, I'm talking about that video. Remember the stack and the heap. You're gonna have a storage area here, right? Called the stack. So everything is allocated on a stack, and then when you want to make use of the heap, you use the new keyword. So remember, I'm gonna copy this, and then this will be the the one on the right hand side is the heap, right? So I'll just name one of them because, like I said, there's no time to be redoing this thing. So this is the heap, right? You're gonna have a variable, some variable here on the stack. In this case, our variable is what? Underscore pixels, right? It's saved on the stack. So underscore pixels. And then I use the new keyword to say new uj pixel, which creates a box on the heap, right? It creates that box on the heap of type uj pixel. And then this now points to that heap. It stores that address, right? So far what we've done by deleting this, okay, eventually when it gets to this part over here, that means the box has now been fully deleted. So it means that we have this. But look at the arrow. We still have the ability to point there, but is there anything there? Nope. So to avoid the user pointing there when they shouldn't point there, there's this technique called null pointer. So you need to literally tell it to point to nothing. Null pointer just basically this a backslash zero or the integer number zero. So we redirect it to make it point to this, to make it point to nothing, basically. So that when the user tries to dereference memory that has been deleted, it will tell them, well, you are trying to point to nothing. What are you trying to do? There's nothing there. So I need to say underscore pixels is equals to null pointer, right? Let me just double check. Okay. I almost thought I wasn't recording. So I've set it to now pointer. So I've disconnected because that memory is no longer in existence, right? So this is very important. So yeah, and then I'm gonna go here and say, and now I can call my helper methods. So I call the distractor. All that does, right, calling that method is just going to say, it's just going to copy and paste this where that function was called, it replaces it with that code. That's literally what it does. So since I'm going to repeat this code, I'll just make my life simpler by just calling the helper method. And then let's scroll up, up. So let's do constructor chaining. So the helper methods in terms of constructors, right? Remember what I said, you always make use of the constructor with more parameters. So calls and then pixel, right? So we're gonna call the helper method here, which is called constructor because it mimics the code for the constructor. And then rows calls and then pixel, right? Then we now chain all the other constructors to this Murena here, this one which has the actual implementation, so that we avoid repeating ourselves again. Remember, repeating yourself is not really a good thing. So you're gonna chain. That's how you avoid repeating yourself. You just chain. Chaining is in terms of constructors, right? It's exactly the same as this thing that I was explaining here, like calling this helper method. So it just goes to that thing that you've called, copies and paste the code within that thing. So in terms of constructor chaining, when I chain to that constructor, it goes to this constructor and then it copies this line of code that's inside that constructor and it pastes it here. And then it pastes it here. That's what it's going to do. So I don't want to type that. I want the computer to do it for me. I don't want because I don't like repeating myself. So UJ image, if you look at the constructor, it expects how many arguments? 3. So it expects me to pass in the rows, which is these rows here. Don't be confused. The rows that I'm about to pass now, it's these rows here. So I'm gonna pass those rows, and then what else? These columns here. So calls. But then if you look at this constructor, it doesn't take in a third parameter. So we need to use a default pixel. So we need to use our own value since it doesn't take a pixel. So that's why I use default pixel there. And then I go back up to this one and then UJ image. This one is nothing. It literally has nothing. So I need to pass all three. So I'm going to pass default rows and then default calls and then the default pixel. So yeah, it's that simple. We're done with our constructors. Let's quickly do the copy constructor. So as you can see, when I'm implementing, you see that I'm giving my parameters names because I actually want to use the values of those parameters since I'm now in the implementation file. So here I'm going to call the copy constructor helper method, copy constructor, obj, right hand side. And then we're done. Now I can use the stream insertion operator to print, right? You need to go back to that. You see, you keep scrolling up and down. So let me go back to that operator overloading. You see, the cell should output a P3 ppm image. P3. So P3 means that when you output, so remember now I need to make use of the values of my parameters. So I give them names. So I'm going to call the first one OLH, meaning an O stream on the left hand side, because it will be on the left hand side of the operator. And then OBJ RHS, which means my object on the right hand side. Because remember it doesn't matter which operator you use, but it's always the case that you have a left operand or a value on the left, and then a right operand or a value on the right of that operator. So for example, 1 plus 2. 1 in this case will be on the left hand side, right? Straightforward. And then 2 will be on the right hand side, straightforward. In my case, I don't have on the left hand side, I have a O stream object. So O stream, right? And then the operator, it's no longer a plus, but instead it's a stream insertion, which is still an operator. And then on the right hand side, you have OBJ, right hand side. So you see that on the left hand side, I have an O stream. On the right hand side, I have, okay, it's a UJ image. I have a UJ image. So that's pretty much what I'm trying to say there when I'm creating those variables. And then remember, O stream is we basically using O stream the same way we use C out. Like we use C out, then you say C out P3 like this, right? And then you put an end of line character. Remember I didn't say using standard namespace, so I always need to fully qualify it. So I said C out, blah blah blah. But in our case, we're not using C out. We're using this OStream object. So I'm gonna use that there. And then remember, after outputting what type of image it is, whether it's a P2 or a P3 or P1, you also put an end of line character to move to the next line. Then you output the number of columns. Number of columns for what object? This object. So everything I'm going to use that object's name. So obj right hand side dot, it's columns, not this, it's columns. And then followed by a space, then you output the object's rows dot underscore rows. And then you move to the next line. So you insert an end of line character, right? And then you output the maximum intensity. Basically, this is the maximum that each pixel can be. Remember, the maximum for all pixels, whether especially P3, it's 255. So I'm gonna output 255. And then I also put an end of line character and then semicolon. And then you are done with the top part. So the top part just tells that program that's opening your image that what type of image it should be so that it knows how to interpret it. Then also specifies how many columns and rows it has so that it knows how big the image is. And then the maximum intensity, it knows, okay, what's the maximum of each pixel so that it knows, oh, so if it's maximum, when it sees a 255, then it knows that that pixel should be white because the higher the value, the more white it is, right? So 255 being white, the smallest value or the minimum intensity, which is a 0, it equates to a black, the color black. Then now I go through every single pixel. So unsigned, short r is equals to 0, r is less than obj, right hand side dot underscore rows, and then for unsigned short c is equals to 0, c is less than obj right hand side dot underscore calls c plus plus, yeah, c plus plus, and then now we can output the object. Remember how you should output the object. You should output the color red, the red color component, followed by a space, and then you output the green, followed by a space, then you output the blue. If you don't do it in that order, your image won't render properly. So remember, I'm using my O stream, right? Which is the same way, works the same way like C out. So insert, I want to get my, okay, so I need to go to the object and then get its pixels at that specific row and column, then get the red color component. So it's quite a lot, and it's a handful. You have to go to that object, get its pixels array, but then remember the pixels array at row C, right? Remember why this is possible. At that specific row and column coordinate, you get back an actual UJ pixel, right? And UJ pixel is what? It's a struct. So hence I use that dot again to say go within that struct to get that red color component. And then remember what I said, each pixel is separated by a space. If you don't do this, follow it in this exact same order, it's not going to render well. And then rc.green RGB. So after red comes the green color component. And then the last one, RGBB. Now we're left with blue. So dot blue. And then don't forget that space after each pixel. And then once you're done, since we want it to render in terms of a grid form, if I leave it like this, right, what's going to happen is that it's going to be in one line. Let's say it's going to say 255, 34, 12, blah, blah, blah. You see, it's going to be in one line like this. It's now in one line, which is a problem. What I need to do is that once I've reached the last column, assume this is the last column, I need to append a new line character, meaning that it's going to move to the next line like this. And then you see that it's starting to form a grid. So I need it to be in sort of like a grid form, like a matrix, right, in maths. So all left hand side, insert this then the end of line character. So this part here, it allows me to 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 shape it in terms of a grid form, which is good because we obviously want it to be, if it's in a grid form, that means we can see it like this, like a square. And then after you're done with everything, then this function expects you to return an O string. So it's simple, you just return that O left hand side. And then you're done outputting. So we are done overloading that operator. And then we go to our accessors. So this is our accessors. So our accessors are very simple. You just simply return. So return underscore rows, and then return underscore columns. Didn't we have an enforce range here? Okay, I didn't. Yeah, we need an enforce range because our pick, we can't, remember, you can never fully trust a user. Users are very spiritual. They like to do things their own way. So make sure that you have a helper method. Remember, any function that's private, it's called a helper method because it's meant to help you write less code, help you, yeah, things like that. So I'm gonna call it enforce range because it's meant to enforce the range, or you can call it check range too. That's fine. Then it's going to take in three values, three unsigned shorts. Unsigned short, and then unsigned short, right? Three unsigned shorts or three integers, whatever you want to, however you want to declare them. The first short or the first integer that it takes in is the value to be checked. Then the second parameter is the lower bound, meaning the minimum that you expect this value to be checked to start from. Then the other one is the upper bound, which is the value that you expect this value to be checked to stop at. So that's why we take three parameters. And then I'm gonna go to my UJ image. I'm gonna put it down there towards here. And then since it's not gonna fit on my screen, I'm gonna do this so that it fits, so that you can see clearly. And then since I'm going to need an exit function, right? It's part of what the library called C standard lib. So hash include cstd lib or C standard. Remember, STD just stands for standard. C standard lib. And I'm gonna need an enum and use if you see the practice this main, right? It always has an enum. You see here. This is Dr. Stung assuming that you're gonna create an enum or that constant. In enum, an enum is an easier way to create the constants. Because if you look at it, imagine, look at all the constants. Remember, we always have to say static const, blah, 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 static const, we have to always call them like that. Isn't there a better way to create constants? Yes, there is. You use an enum. So I'm going to say enum. You can give it any name. I'm going to call it status or status code. There's a status code, meaning it just returns the state of my application. In what state is it in? So it's going to have error in range, right? I'm going to create a constant called error in range. And then since Dr. Stung expects me to have a success constant, so I'm going to create a success constant. And then you can leave it in this way. And if you go over the constant, it will tell you what default value it is. You see, it starts at 0. And then this starts at, let me see. Okay, yeah. This is equals to 1. And it increments by 1. So it starts at that first constant. When it moves on to the next constant, it adds 1 to the value of the previous constant. So since, remember, your main.cpp, it should return 0 here. Or you can create a constant and put 0 inside of it. So that means I need to make sure that this enum, that success is 0. How do I do that? By making this one to be -1, because -1 plus 1 is 0. So if you go here, if I go over here, then I wait for it, you see now success is what? 0. So that's, if I add another variable, that means I'd have to change this to -2. So yeah, it's something that you have to do. So error and range. So now I have those two things. I'm good to go. And then before I forget, I need to specify this. This is part of UJ image. And then and then I like my things aligned. So I'm gonna have three things. I'm gonna have the value, right? And then I'm gonna have the upper one, the lower one, which is lower bound. And remember, don't name it like this. You see, there's already something called lower bound reserved part of C++. Don't name it like that. So use camel case, lower bound, and then upper bound. And then it's pretty straightforward. You're gonna say if value is less than my lower bound, right? And then, okay, let me just do it everything here. And then I'm gonna output an error. So standard CR, ERE just stands for error. It's an error message. It works the same way as cout, but cout, remember, is just normal output. CR, it's an error, it's actual error. You might not see any difference, but just use the right tools. So what's the error? Value is what? Less than that minimum or that lower bound. Then I need to move on to the next line or insert an end of line character. And then once I'm done, I need to exit or stop my app immediately because that means the user gave me the wrong details. What integer am I going to exit with? Therefore, this is now where I use those constants that I created in my enum. So that means there was an error in range. In my range, there was an error. So that's why I'm exiting with that status code. And then in the next, I copy that and paste that if statement because I'm checking if it's below the lower bound, and I also need to check if it's above the upper bound. So that's why, because you see that I'm basically doing the same thing. But then remember, the symbol needs to change. Mathematically, it makes no sense to say you want to check if something is above the upper bound, but you're saying it's less than. You have to say greater than. If it's greater than the upper bound or the expected upper bound, then the user has entered an invalid value. So I need to change the error to say value is greater than, and then also need to change here to upper bound. And then that's all you have to do to check the error, to enforce the range. Then now we need to go to all the functions that make use of this, that should make use of this. So we need to remember our pixel. We need to enforce the pixels too. Remember, red, green, and blue needs to be within that range. And if you check the practical test, they told you. You see, it's between 0 and 255, between 0 and 255, between 0 and 255. We need to enforce the range. So it's going to be quite a lot of enforcing, a lot of code. So enforce range. And then what am I enforcing? The rows, they need to start from where? 0 up until some size, right? So you see that we're gonna be reusing, because the same way I'm gonna check the rows is the same way I'm gonna check the columns. So therefore, to avoid repetition, I'm gonna create constants for those. So static const, unsigned, short, I'm gonna call it min size. For the minimum size, I'm gonna say is equals to 0. Constant, right? If you notice something, constants, they give value or meaning to numbers. Because if I just typed 0 into my app, 10 years later, if I look at this code again, I'm not going to understand what that 0 meant. But if I give it a name, I give the 0 number a name, I know, oh, it's the minimum size. It makes life easy. So unsigned max size. So the max size can be anything. Remember, if I use unsigned short, right, that means the range of integers that variable can represent, it's between 0 and 64,000. So I need to make sure the value that I enter is not greater than 64,000. So in my case, I'll just say 10,000. Obviously, no, the user won't get to that value, but it's just an arbitrary number that we come up with. But remember, since I'm counting from 0, you don't stop at 10,000, you stop at the number before. So you actually need to say 9,999. But we just don't type it directly. We'll just subtract 1 whenever we use max size. We'll just subtract 1 from it. And to make the 10,000 easy to read, you can put an apostrophe anyway to make it readable. So I want to put it here so that the user can know, oh, this is 10,000. That apostrophe doesn't change the integer. It doesn't do anything. I'm just putting it there. And then I also need for my pixels, right? Because remember, my pixels have a minimum range. So I'm gonna say minimum pixel size, right? I'm gonna call it minimum pixel size is 0, and then static const unsigned short maximum max underscore pixel size. The maximum for the pixel they told you it should be 255. So I have min size, I have max size, and then I have min pixel size, and I have max pixel size. So I need to use that. So my rows need to be at least 0. So min size. And then it stop at max size. -1 because you're counting from 0. Remember, when you're counting from 0, you don't stop at that specific number. And then I'm going to repeat and do the same thing for my columns. I'm going to do the same checks. So hence I just copied and pasted. And then now I need to enforce the range. So I'm just going to copy and paste, even though I'm going to delete. So I'm going to go to my pixels color components. So remember, it's a UJ pixel, it's a struct. So I need to say dot to go within that struct. So dot red, get the red color component, and check if it starts at minimum pixel. How come it's not picking it up? Pixel size. Yeah, but I'm sure you should pick it up. And then minimum, no, maximum pixel size. Yeah, it is there. I don't know why it's not picking it up. Yeah, and then I'm gonna repeat that check for the pixel, right? For the pixel, right? For all the other pixels. So I need to copy this 2 more times. And then red, green for the green color component, and then blue to check the blue color component. And then you're done. You've really, really enforced the range here. So since we've enforced the range, that's good. And then Where else should I enforce the range? Yeah, okay. So let me implement my accessors, right? Um, so my get pixel, remember we have a get pixel which takes in a row and a specific column. So it needs to go to that specific row and column. So I need to make sure my row is valid. How do I check my row? I enforce that my row is between 0, at least minimum is a 0, which we've saved as mean size, if you remember, is the constant mean size, up to underscore rows minus 1. Minus 1 because we're counting from 0. Mean size is 0, remember. And then I'm going to enforce range for my column, starting at mean size, stopping at underscore calls minus 1. Then I've enforced the range for both my row and column. So I made sure the row and column is valid before trying to access the pixel. Then now I can return the pixel. So return underscore pixels in that specific row, in that specific column. And then I'm going to do this exact same thing when I'm setting the pixel. You need to remember, you need to make sure you do this check, so else your code is going to crash and you won't know why. And then I'm going to give my parameters names because I want to access the actual values. And then since I'm lazy, right? I'm going to go copy and paste from that file where I validated the pixels, these 3 lines. I don't want to type them again because I need to validate again. Since remember, I'm getting a pixel, so I need to make sure this pixel that's being initialized or set, it's valid, it's within the range. That's why they told you to enforce the range. So you see, it's quite a lot, right? It's quite a lot of checks, but you have to be I feel like in computer science, you have to be a bit psychotic. You need to make sure that everything needs to go the way it needs to go. So that means you need to put in all the checks. And then what is this function supposed to do? It's supposed to set. So by setting, another term, the actual code to set anything is like, for example, x is equals to 10. That means I'm setting x to be the value 10. So that's how I'm going to set. But what am I setting? The pixels. So pixels at that specific row and then at that specific column, set it to that pixel. And I've validated that pixel. I've also validated that the rows and columns are valid. So this, when it gets to this point in time, line 73, that means that everything is valid. Then it sets the pixel. I know it's quite a lot to take in, like to check and whatever, but you have to do that because you can't think for the user. The user is not like you. The user is bound to make a lot of mistakes. So for this one, I'm going to do checks, right? I'm going to avoid reassignment. So we're overriding the operator equals to. What does that mean? It means that I can be able to say obj1 is equals to obj2. That's what it means. So what we need to avoid, right, is what if this object2 already has the same value as the values inside object1? So there's no point for me to copy. So I need to avoid what is this self-assignment. So I'm going to check my address by using this keyword, meaning this instance, this object, which is me. If I'm not equals to obj right hand side, right? But then remember this keyword is a pointer. When you remember a pointer, if you use it without that star, that watashi wa star, if you don't use it without that star, you're actually referring to the address. So therefore, this object, I need to say its address of object right hand side, because I should be comparing addresses here. So if they're not equals, or basically they're not the same, then I can do the deep copy. So how do you do the deep copy? It's simple logic. Since we have helper methods, it becomes very, very simple. It's surprising how simple it is after when you do everything. So I'm going to start by deleting, right? So you destroy any memory that's there. So this is that process. This is that moment when you throw away the glass. You realize, oh, the glass is not the same size as this 2 liter bottle or 2 liter of Coke. So I need to throw away the bottle. Just throw away. So I need to call the distractor helper method. Once I've thrown away that bottle, I now fetch a container that's the same size as the object that I'm trying to copy from. So basically, I'm trying to pour from that 2 liter of Coke. So I need to take a 2 liter container. So now I allocate memory to make sure the objects are of the same size, right? So I call what? Constructor helper method. And it expects me to pass in the rows and columns. So which rows and columns am I passing? From that object that I want to copy from, because remember, I want me to be the same size as that object that I'm copying from. Hence, I'm going to say, take the rows from that object, also take in the columns from that object. And then it obviously going to require you to pass the pixel, a default pixel. So we can just pass this. Remember, we have a default pixel here, right? We can just say default pixel. Since there's no pixel declared in the private section, right? If you check, you see there's no pixel here, 1 pixel. It's not there. So we have to use the default pixel. Either way, that default pixel will be changed. It's fine. Can just put a default pixel. Then now, since we are sure we are of the same size, I've taken a container that's also 2 liters. Then I can now transfer values. Transfer or copy. Remember, we're trying to copy values or transfer them. So now I can pour that from that 2 liter to another 2 liter confidently because I know everything will be stored in that container because since they're of the same size now. So I call the copy constructor helper method. And then I take the object that I'm trying to copy from, which is obj right hand side. And then once I'm done, I return myself to see whether I've actually made changes to myself. So I just return this keyword, but then this keyword, remember, if it's used without that star, that watashi was star, it doesn't actually return the object. This function expects it to return UJ image. So I need to point, so dereference point to this address to get back that actual object. And then done. And then the other operator, you need to actually see the code to see what's the requirement. So support for pre-increment, right? Which loops through the array and adds 1 to the color components for each pixel, which is very, very straightforward. So I'm going to say for unsigned short. Remember, they say go through every single pixel, right? Let's start by doing that one thing at a time. I'm now going through each pixel. It seems like this kid in the group chat are chatting. Nah? And then C unsigned, yeah, and then C++. So I'm going through all the pixels, right? So to access all the pixels, right, I gotta go to that specific row and column, and then you say dot to get that color component, right? So let me just access all of them for now to show you how easy this thing is if you really understand the instructions. So I have all the color components. So what are they telling me to do here? They're saying you need to add 1 to color component, each of the pixels. So how do you add 1? What is pre-increment? Remember, the pre-increment is before, meaning you're going to put it before the actual variable. So plus plus like this. And then you put plus plus again there. And then you put plus plus again there because you need to increment all of the pixels. And then done. That's all you have to do. So sometimes you might feel like this thing is hard, but if you actually sit down and unpack it and think about it, you realize it's actually not that hard, straightforward. You see, some students would have panicked in this part for pre-increment. But then if you look at the code, it's just straightforward. Try to understand what you're being asked to do. Yeah, we've implemented quite a lot. So let's read from the far, right? Let's look at what you're supposed to do. File handling is the trickier part, but it's also not hard. Mm. Okay, so on the first line, okay, it's not, since we're using init large, right? We are using the different files, so we need to check init large because I want to load from init large. So I'm gonna go to code blocks project, go to my project, right? And then I'm gonna open, and then this init large, and then I'm going to edit with Notepad plus plus. Well, my Notepad plus plus was giving, it had issues. I forgot. I need to delete that Notepad. I forgot it has issues. Don't know why it has those issues. It's like it wants some smoke with me. So there's the, yeah, it's true. You see what they said is true. You have this, right? 500, 500, 500, and then you have that N or Y. So you need to read all those three. And they see they didn't lie. They said on the first line you have rows, columns, and stochastic, but right? But that stochastic, it's either a Y or an N, meaning yes, it's stochastic, and no, it's not, meaning it's the other one. So yeah, so indicating the rows. So I need to store that. You see this variable, this yes or no, I need to store it. So I need to create a char. Since yeah, you must normalize storing those things from the file. Sometimes they can say it's a boolean, true or false, but in this case this shows a char. So char, I'm gonna say stochastic. Yeah, I'm gonna call it underscore stochastic, which stores whether it's a stochastic or not. So if that character is a Y, then yes, it's a stochastic. If it's a no, then no, it's not a stochastic. Meaning it's the other one, it's the other child. So it passes, you take in the rows and the columns for the image and then that character. So let's start doing it, right? So in order for me to read from the file, I need to import or include the f stream, right? So hash include f stream header file. Since which is F stands for file, so file stream. So we're dealing with files here. So from my standard namespace, I want to make use of the if stream, right? I stands for input, so input file stream. So I'm getting input from a file. So f in, I'm gonna call it f in, and then at the end of the day, I need to close my file, right? So close my file, and then you can do it in many ways. You can do it in the next line and say f in dot open to open the file. Or you can do it in one line and just call the constructor and then just pass in the file name to open the file. It's up to you, whatever the approach you want to use. So since I've been using that other one, let me use this one where we call the actual open method. So open means open that file. Then you obviously to open the file, you need to tell it which file to open. So open this one file name. Come on, file name. Right, it's gonna try and open that file. And then we could throw an exception or whatever when an error occurs. I'm not gonna do that now because I feel like you should don't worry about the bonus. Just try to do the full paper. The bonus is for advanced people when you're done with this and you wanna test, push yourself way past your limit. That's the bonus. Here, just do it. I'm gonna teach you just to do the actual project, the actual practical, not the bonuses. So open the file and remember before we start getting all the lines, right? What I'm going to do is basically before I start using a while loop, I'm gonna get the first line. So how do you get the first line? So we're gonna need quite a lot of things. So I'm gonna need the string stream, right? I'm gonna call it SS, and then I'm gonna need a actual string, which will store the line that I'll get from the file. So I'm going to use this function called getLine. So standard getLine, which gets a line from that file stream or some input stream. So which input stream am I getting it from? F in, comma, and then you pass the string where you want to store that line. Because remember, it's a text file, meaning it interprets it as a string. So you need to store it into a string variable. So store it inside the line, which is a string. And then once I'm done, I need to insert that line since I have the line, right? So what's going to happen in this part here that I'm going to highlight here, it reads the first line, hence called get line. Gets the line from f in, which is that f in is linked to what? This file. So basically from that file, get that line. And then that line is stored inside here. So in a way, you can view this as like, it's going to do this. It's going to have 500, 500, and y, right? That line. So in order for me to split it up and get the individual values, I actually need to put it into the string stream first. So I need to say SS, and then I insert that line into the string stream. Then now I can say SS and then extract. You see the direction of my arrows. It means that it's going into that direction. So yeah, so since I'm going to need, okay, remember for rows, yeah, okay, okay, I can continue. So remember the first parameter, this one, remember in the same order that you're inserting it in is the same order you're gonna extract it in. The first parameter they said it's rows. So I'm going to say underscore rows like this. And then I'm going to say SS and then underscore calls like this, right? And then the last one is Y, which is that stochastic. I created a stochastic variable. So SS read underscore stochastic, right? And then once you're done, what happens is if you don't delete what's the string stream, right? Remember the string stream will have this. And then let's say we get the next line. So let me open this file. Let's say we get this line. And then it's going to append it to the end of the line. So you see, now we end up having something spiritual like this. And then you read the first three, which is which three? Which is just this again. So you see, you keep rereading the first three over and over and over and over, which is a problem. So we need to only, after you're done reading that thing, you need to clear the buffer or delete like this. Then you read the next line. Then you clear, then you read the next line. So that's someone or some people asking in the group about it. You need to clear. So now I need to say ss.clear to clear my buffer. So clear the buffer. If you don't, you'll face issues. And then I'm going to do a while loop now. So remember there's multiple lines. You see the nice thing about a while loop, it runs as long as that condition is true. So look at the while loop. While there's a line to get, so I'm going to use the get line within the while loop condition. So it's going to check if there's a line to get within that file. So while standard get line, so this get, while there's a line to get, then it gets the line. So get from my file input stream and then straight inside the string called line. While there's a line to get the line. So the line, if you look at the line, if you look at the PDF, how it explains the line, you're going to have a specific row, column, and seed values, right? Seed value 1, seed value 2, whatever. And the seed values, they differ from time to time, right? The seed values are not the same, right? So since the seed values are not the same, um, that means I'm going to need to create a counter. So, okay, before I do that, I need to have, remember they said you're getting back a row and a column. So I need to say unsigned short R for to get to initialize to use that row, and then C is equals to 0, right? To store every time I get the row, I store. And then I'm like I said, I'm gonna need a counter. So underscore counter is equals to 0, right? And then yeah, it's fine. The counter is fine. So remember what I said, you need to always insert into the string stream. So remember the string stream is empty now, we've cleared it so that we can insert the line again. So this inserts into the string stream, right? And then now we extract each value from the string stream. From the string stream. So remember in what order it is in. You start by extracting the row and column. So RC. I've created a variable for that. So extract R. And remember, if you're extracting multiple values, you can, instead of writing line by line, you can just write in one line like this. So extract R first, then extract C in that order. So that's what it means. And then the seed values, I do not know how many they are, right? The seed values. I do not know how many they are. So there's multiple ways I can go about doing it, right? So, let's just say it's one way. So since I do not know how many there are, I'm gonna use the while loop. So I'm gonna say while what? So I need this becomes a bit of work. So unsigned short, let's say value, right? Let's call it value. Is that value, right? That value going to be, which is the seed value. So remember what I said, you can also do this in C++. You can say you can put this within the while loop and then while ss dot value. This just means while there's a value to get from my string because remember, look at the order of the symbols. It's greater than, meaning that it's traveling from there and it goes to there. So if this operation is true, that means execute while it's true. So that means as long as there's values to read, which is a very good technique because you see that the numbers are not always the same. So for example, in this first two two ones, there's three, but then all of a sudden now there's four here. Now there's five here. Now there's two here. So you see, I will never know exactly how many there are. Hence, I use that technique. So while there's more to read it into that string value. And then remember, I need to store it into my array. So array at that specific row and column, the one that I read from my file, um, remember it's a UJ pixel. We have this seeds array. So I need to go access that seeds array, which is quite a lot of things quite a lot to think about. Dot seeds. And remember seeds, you need to index to get that specific seed. So dot counter. Hence I use counter. Remember array is a zero index. So counter, I started zero. And then counter, and then I set it to be equals to that value from the file. That value from the file. Then I need to increment my counter, right? So counter, why am I incrementing my counter? Because if I don't increment my counter, that means it override only the first element because remember counter points to the first element, which is index 0. So once I've done with this, I need to increment my counter. So counter plus plus, right? And then since the array at each row and at each coordinate, the array will be different. That means I always need to start my array at 0. That means after this while loop, I need to set back my counter to 0. Set back my counter to 0. So that it starts at 0 again to when it gets to the next coordinate. So I'm gonna say counter is equals to 0. But then we're almost done. Almost done. We're missing one line. Remember to always clear the buffer. So clear the string stream or the buffer. So I need to say ss dot clear. And then we've read from the file. That's it. We've read every single pixel from the file. And then don't forget to close the file. And then to write to the file, let me see how much time we've pushed now. It's 1 hour 28. Yeah, but I think we should be able to push now and we'll see. So let's write to the file, right? Remember to save to the file, it's always the same. That part doesn't change. When they say save to the file, where is it? Yeah. So add a member function to UJ image, which will save all the pixel to a binary file of records. So it will never change. You're always going to write to a binary file. So, okay, it might, don't know, but most of the time it hasn't changed ever since. So I'm going to say standard OF stream for output file stream, and I'm going to call it F out because I want to output to the file, right? And then at the end, I must always not forget to close the file at the end. And then I need to open that file. So f out dot open to open that file with that file name that's being passed here. And then I need to specify the mode, right? So if you do this, if you check something, look at by default, the mode is what? iOS base dot out. By default, it's in out mode. So what I need to, it's fine that it should be left in output mode. But then I also want to add more to that output mode. So you should also say iOS. Okay, I can say iOS, yeah, iOS. And then, so standard namespace, because I didn't say using standard namespace. So input output stream, iOS, that's what it stands for, input output stream. Get a constant from my input output stream. I want the constant called binary, which says that open the file in binary mode. I want to write it in binary. That's what it means. Because by default, its output mode is in text. It expects you to write to a text file by default. So what we can do is we can change those settings and say, no, I don't want those default. I want to write it in binary. And then in binary, like I always say, it's not gonna change the code. Yeah, never change. The thing that might change is the names. Maybe it's no longer called UJ pixel, it's called UJ color. So underscore rows R plus plus, and then for unsigned short C, and then C is less than underscore calls. Now I'm going through all of my pixels, right? Then I use my f out object, f out, and I call the write method because I'm writing to a binary file. So the write method, right, it expects you to pass two things, a const char pointer and the size of that data type in bytes. So since our array, right, remember array is not a const char pointer, it's actually a UJ pixel pointer. So that means we want to convert from one pointer to another pointer. We use what we call a reinterpret cast. So reinterpret cast like this, and then within the less than and greater than symbol, you pass the type you want to convert to. Remember what I said, we want to convert it to a const char. And then what are we converting? The pixels. So underscore pixels are C. But then remember, since you're converting it to a pixel, you need to pass, this is a pointer. It expects you to pass the address. So address of my pixels. And then the size of, you just pass in the name of that record structure, or you can just repass this. It's fine. It's up to you, whatever approach you feel like it's easier for you. You can just pass in the pixel underscore pixels RC because remember at that coordinate RC, we get back a UJ pixel. That's why I said you can choose any technique. You can just get the actual UJ pixel, or you can just say the size of that UJ pixel. That's up to you. And then done. That's how you write to binary. It will never change. This write to binary, always be the same. So now we can do okay. Now you're not gonna like this because now we need to change a lot of stuff in terms of remember they said you should call this, you should read from the file within the constructor. So and the constructor uses the a constructor helper method. So that means I need to put that code within the constructor helper method. So a lot of things are going to change. So what I'm going to do is I'm going to delete this, right? Um, remember the rows and columns, I'm getting them from the file. So it actually means that this is actually pointless now. My constructor doesn't need these rows and column, but it's fine. It's fine. I'm just gonna leave them there. So that means I need to enforce, I'm enforcing the range in the wrong place. I need to go to my file handler, file function that reads from the file. When it gets the rows here, you see this part here, we need to enforce those rows. So underscore rows, underscore rows, and then underscore calls. right? I enforce them immediately after getting them. And then the stochastic, it doesn't really matter. Um, Hello, what happened?
I was trying to charge my laptop and then I switched it off on mistake.
Oh, okay. It's cool. You agree, I'll send you the recording. So if wherever you missed, then you just continue from there. Okay, so the rows, blah blah blah. Let me think about it. Hmm. Like I don't see the necessity of this thing anymore. So it's going to be tricky though. That's going to be tricky. Let me. Mm, I'm trying to think about it because okay, this is a bit tricky. It's a small issue though, but it's a bit tricky. I see why I need these rows and columns because when you get to the assignment operator, they are needed because I need to extract those rows from that other object. That's why. So they still need to remain there, but they're not being used. That's my issue. Since I'm setting them here, you see, this is where I set them. So I'll see. Let me see. So you take in the rows and columns, right? Let me think about it. You take in those rows and columns from that object. Okay, yeah. Let me just use those rows and columns. Okay, I don't know why I was overthinking it. Let me just use those rows and columns. So I'm gonna use these ones that are being passed. Yeah, that's the only difference I'll make. I'll just use the ones that are being passed. So we technically, since they're being passed here, right? Since they're being passed here, um, okay, let me think about it. Hey, my brain, hey, this thing it's my brain is like confused now. This thing is because I don't want you see I'm avoiding to remove the columns. They are not necessary, right? I'm avoiding that. I know they're not necessary. I'm avoiding that to remove them. Why am I avoiding to remove them? Because if I remove them, when it comes to my assignment operator is gonna stop working now. Because remember the assignment operator, it requires me to take the rows and columns from that object, right? So okay, let me think about it critically. So yeah, remember they said we need to load from the file. Let me call that file. So before I do anything, right, I need to call my load from txt, right? And then I'm loading from which file? It's called init underscore large dot txt, right? That's why they said load from the file. So here I'm going to say read from the file. And remember this method over here that reads from the file. It reads from the file and then it initializes the rows and columns. So my rows and columns are now initialized. And now the question is, what about this? I guess we can remove it. I guess we don't have a choice. Let me think. I don't want to remove. Let me think. What solution can I come up with to avoid this issue? Because the assignment operator is indeed needed. So, and I don't want to repeat my code. So load from txt, we do that. And then it initializes underscore rows and underscore columns, right? My underscore rows and my underscore columns. Yeah, this is wrong. Let me not call this method because this is a different scenario, right? Yeah, this is not right. So here I'm gonna say underscore rows underscore columns. No, and the hey wish you wish. This thing is it's yeah, it's really your code is going to crash dismally. I don't know why they like to confuse students. Like I don't know why they did it this way. Because you see that here, but it's fine. Now let me do this. It's fine. Yes, yeah, yes, it's fine. Let me. Yeah, I came up with a way. Let me think about it. Since I'm reading from that file, right? Yeah, let me do it this way. Let me leave this one to actually have those things, right? Let me leave it like that. Let me come up with the way because I think I have a solution for this. So what I'm going to do is I'm going to come here. You see, immediately after doing this, right? Remember, I can't just leave the array. You see this array over here, this one. It hasn't been allocated and I'm already using it, which is a problem. So immediately after getting the rows and columns from the file, I call my constructor method to construct the object, and it takes in those underscore rows and columns, and then that default pic, just a default pixel, right? I need to call the constructor because if I don't call the constructor, what's going to happen? This will crash. This pixel hasn't been allocated memory. So that's why I was saying I need to do it this way. So I call the constructor, and then that other code, the way we leave the way it is, the rows and whatnot, those rows, those columns, blah, 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 and then we check. Yeah, I think that should be fine. Yeah, if I leave it as it is, I think it should work. Is equals to that pixel, rows, and then this is calls, not underscore calls, it's calls. Yeah, I think this should be fine. Yeah, I think we did fix the problem now. And then now the issue is, you see, if I do it this way, you see, this becomes really annoying. If I do it this way, right? Now the question is, where will this function be called? Because they expect you to call it within the constructor. I don't know why they did it this way. This is really confusing. Even for me, it's confusing. I don't know how they expect you to do this the right way. So you see, they said add a member function to UJ class, which will load the information from the provided text file, right? This function must be called by the UJ default constructor. So they want you to call it in the default constructor. So, oh, the default constructor. So let's call it. Let's use it in the default constructor. Then let's see. So if you don't want us to call it here, right? The thing is, mm, yeah, those people are mad. I don't know how they expect you to call it from there. Yeah, this makes no sense. I don't want to lie to you. It makes no sense. Let me tell you why it makes no sense. Yeah, this is one fucked up way to make students fail. How are you saying that you want the method to be called within the constructor, but that same method, right? You are calling it in the constructor, but remember what the constructor does? It initializes, it sets that thing to rows and columns, but you actually need to get the rows from the columns from the file. So what do you mean? So you see, now it becomes very confusing. So which is which? Because I need the rows and columns to initialize the object, but you're telling me to call it within my constructor, which is very confusing. So yeah, I don't know what went into their thought process when they're creating this paper, because this makes no sense. It actually makes no sense at all. You're going around in circles now, the way they've structured this paper. So let me see. Now I need to come up with a solution for to fill in for the incompetence. Hey, why couldn't they structure this paper well? Hey, as a lecturers, man, whoever came up with this paper, it was high because you're getting the rows from there, and obviously you can't use this part here, this array, without initializing it. So it's vice versa. You need to call the constructor within the load function, not the other way around. So me, I'll do it that way because whatever way they're talking about, there's no way that'll work. So I'm gonna call the load method within the main.cpp. I'm not gonna do the way they're expecting me to do things because it makes no sense. it doesn't. No matter how hard you try to reason, it doesn't make no sense to call it that way. So I'll leave this code as it is like this. Yeah, it should work fine if I leave it exactly the way it is now. Because when you call this constructor method, it allocates memory for that pixel array. Then, okay, I'm doing it in the wrong order. I need to enforce. Oh, no, it's fine. I don't need to enforce the range because remember the constructor already enforces the range, right? You see, there it is here. So I don't need to enforce that range. I just call the constructor method, the helper method, then it constructs, right? And then save to that. Yeah. So before you continue, I'm gonna make sure I call that read function right. So I'm gonna call, I'm gonna come here and say obj image, right? Dot, what is it called? Dot load from txt. What's the file? Init underscore large dot txt. So I'm gonna call it inside main because I don't know what they smoked when they were setting this paper. It makes no sense. You can't call it within the construct. You just can't. So I'm gonna call it in that way. And then now we can do the composition part. Um, but I doubt your brain is still functional. Is your brain still functional?
Yeah.
You can go for how many more minutes? 30 more.
I have class at 1, so if we can finish before then, yeah.
Do you stay close or you still have to get a bus?
I need to I stay close-ish. Yeah.
How many minutes is it? I don't want to
Fine. Like 5
inconvenience.
minutes away.
Or like five, or more, yeah, you are here, Mosau. You
Yeah.
are saying ish, like it's like my 20, or it depends on the pace.
No. I it depends, I guess.
Uh, you say so. So let's create let's let's do the delegation, right? Their delegation. So remember we have that stochastic thingy. So I'm gonna use that to not here. What I always make that mistake within the constructor. Remember we need to allocate life cycle management, right? So life cycle management. So I need to say life cycle management. So I need to check. Remember, I need to have that stochastic thingy. Um, so before, which is very this thing, this paper was shit. I'm not gonna lie to you, this paper was a piece of shit. The way they set this paper. So now I need to get the stochastic before calling the constructor because I need to check its value, this thing, before I instantiate. Hence, I read it from the file before calling the construct. Or you can just do it after you've cleared the buffer. And then that's when you can call the construct helper method. So I'm going to say if underscore stochastic equals to y. Remember, they said when it's y, then it means what? It's a stochastic. Because yes, y stochastic, yes, stochastic. So I'm going to have renderer. So I'm going to have underscore renderer. And then I instantiate it to the child class. So since I don't have the child class, I need to create the files. So I need to create the class. So before you see that because it's really annoying. Now you have to do this before you do that. Ish, it's really annoying. So let's create this. So we need to, excuse me, we need to actually create the stochastic renderer and the other renderer. So stochastic renderer, you see, I went to copy the name so that they match exactly. And then dot age, and then I remove the underscore included. I select all, and then finish, and then view, and then C++ dot cpp and then select all. Right, and then I need to include the stochastic renderer.h header file. Then I create the class, right? The stochastic renderer. So the stochastic renderer needs to inherit from renderer, right? Public inheritance. It means that the things that I am going to inherit as stochastic renderer from renderer class will be made public in my class. And then it needs to know what renderer is. It will say renderer does not name a type. So when it comes to inheritance, you can include the header file within that header file. It's fine because it needs the full class in order for you to do inheritance. You see that I don't do forward declaration. I include the whole header file. And then I need to create my constructors, right? So I'm gonna have a parameterless and parameterized constructor, and then a destructor, then private. We're going to have private information there because they do specify in the question paper. And then I need to override that method, right? So I need to come here and then override this method. But remember, it's no longer equals to 0. I'm going to use the override keyword here, override, which means that I'm overriding it. And then I remove that virtual keyword. I think you can leave the virtual keyword if it's fine, but override, yeah, I think you can leave it or leave it there. It's up to you, or remove it. That's up to you. So a stochastic render, it contains a chance. So when the tells a class contains something, right? Most of the time it means that it's either private or protected. With the base class, just make sure you make it protected. With the child class, you just make them private because they haven't told us that there's any other classes that inherit from our child classes. So they said it's a chance. So unsigned short underscore chance. So that means this constructor will take in a chance. So I'm gonna leave it like that. A chance and then blah blah it draws. Okay, 90% chance. Okay, yeah, so that's fine. Bu- 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 okay, so I'm gonna create a constant, right? So static const in unsigned short, I mean, for a default chance. Because remember we have a parameterless construct. Default chance. This the default chance is 90. Why am I choosing 90? Because if you check on the question paper, when they use 90, you see, when the chance is set to 90, so I'm just going to use 90 as my default. So I'm going to use default constructors here. You can use the parameterized one, then pass the integer 90. But why would you do that? Yeah, just giving yourself a lot of work. But it's fine. You can do that if you want. Okay, that's very spiritual. Um, Copy this. Oh yeah, I made a mistake, and I almost made that mistake and forgot about it. So remember what your child class is, right? We'll implement the other things later, like the draw method. We can implement maybe one of the draw methods quickly. We'll see in terms of time. So if you look at your base class render, right? It took in a position. So you must also take the position. So remember, your base class is just like a template. Then your child classes extend your base class. So that means they have the same things as your base class, but then they extend and add their own unique things. So that means for the parameterized construct, right, you start by taking in the position, followed by the thing that you're extending, that extra thing that's unique to you, which is that chance within this class. And then the default constructor is just still default constructor. There's nothing changing there. So now I'm going to take in a position here, and then uh, come on, I need to put it there. So position. That's what I'm gonna name it, and then unsigned chance. and then I chain to my base class. This is possible because you are inheriting from your base class, right? And then remember my base class, the parameterized constructor, it takes in what? A position. So I'm going to pass in a position here. So I'm going to chain to my base class's constructor, which is the parameterized one, which takes in one parameter, which is of type position. And then since my class has extra thing like the chance, I need to initialize it myself. So underscore chance is equals to chance, like this, right? Done. And then this one over here, this one will just chain to this base to this other construct. So stochastic renderer, default position, comma, default chance. Remember the default position is defined within the base class, which is this one here, default position. So I'm just using that one. And then I've initialized everything 100% perfect. Remember the destructor doesn't need anything. The destructor doesn't need anything. So let's quickly implement this, right? This thing about the chance, whatever. We'll just render one image, right? Stochastic. And then we'll see, but pretty much we've covered everything because the other class is pretty straightforward. You just do the same thing as stochastic. So you have a chance, which is an integer in the range 0 to 100 set during while constructor, right? We did that. Overrides the draw function to perform the drawing method described previously. So since I've defined, before I implement draw, let me go back to EJ image. Remember, if it's a stochastic, then I instantiate it to a stochastic. So I think I called it what? You see this thing of auto completion at the renderer. So underscore renderer is equals to new stochastic renderer. When you say new stochastic renderer like this, it calls the default constructor for stochastic. So hence I needed to create the stochastic renderer. But since it needs to know what stochastic renderer is, I need to include the stochastic renderer header file here. So stochastic renderer header file. And then we need to also delegate. So delegation is pretty straightforward. You just go in to say this, and then you call the draw method from that class. Then you pass in yourself, which is EJ image. Because if you check this parameter, right, it expects a UJ image. So I need to dereference. So I'm going to dereference. And then now you've done delegation. I'm sure right now with what we've done so far, you can get distinction. Yeah, you can get a distinction. And then stochastic render. Yeah. So now we can implement, right? So let's implement stochastic render. Let's see what the logic is here. For every pixel, you see, every pixel. So I need to go through all of the pixels. So unsigned short r is equals to 0. Since I'm now outside the class, I'm going to say obj image dot get rows, right? Okay, something is missing here. Remember, I keep forgetting. Remember that UJ image inside this class, we did, okay, yeah, I forgot. It's going to crash. We need to do a forward declaration here for UJ image, just to tell the compiler that, yeah, listen, UJ image is something, it's a class. That's all you need to know. It's empty for now. So inside here, I need to include that UJ image header file. So hash include UJ image header file so that when I call get rows, it knows, oh, get rows is within that header file. And then for unsigned short c is equals to 0. C is less than obj image dot get calls. That's what I don't like about code blocks. One moment it's helping you out, it's auto completing. One moment it stops. That's why code blocks is the worst idea you can ever use. We have this. Let me zoom out a bit. Yeah, so let's see what the logic is. I've gone through every pixel. It must generate a random number between 0 and 100. You see, very easy, straightforward. They're telling you exactly how it is. So I'm gonna go to my renderer class, right? To my base class, and I'm gonna include CMath library. Remember, I need that rand function to generate a random value. So I need the CMath. Is it the C? Yeah, it's the CMath, yeah. CMath library. I need that rand function. Then now I need to generate a random value between 0 and 100. So let's generate that random value. And they said for every pixel, you see, for every pixel, meaning that we need to be within the loop for the loop for the columns. So I'm gonna say unsigned um short. I'm gonna call it rand chance because it's a random chance, right? That I'm calculating. Or you can write it in full. So random chance is equals to standard, and then I use the rand method. Remember the rand method, its formula is that you're going to say modulus, right? Meaning divide and get the remainder divided by the range. What is the range? It's the upper bound minus lower bound, which is 100. Remember, they said you should generate a random value between 0 and 100. So my lower is 0, my upper is 100. So the range is 100 minus 0, which is just 100. So I'm going to put 100 there. And since I wanted to start at that specific value, if you don't add back the lower bound, right, or the lower value, it always starts at 0, which is fine because what did they tell you here? They said you should start at 0. Either way, even if I add back the lower bound, which is just 0, remember, if you add 0 to any number, you get back that number. So it makes no difference. So I'll just put it there, just remind you that you need to always add the lower bound so that it starts at that lower bound. So I've generated the random value, right? Does Dr. Stung seed the random generate? Okay, it doesn't. You see, they forgot a lot of things. Yeah, so you need to seed. So srand time null pointer so that it generates what is this unique values every time it runs. And then random chance if the number is less than or equals to the chance, which is straightforward. So I need to do an if statement if random chance, right? Random chance is less than or equals to what chance underscore chance that I've already stored. Which one? This one over here. If that random chance is less than or equals to that chance, then what should happen? The pixel must be drawn onto the image. Otherwise, a black pixel must be drawn. The seed value of the random number generator is the sum of all of the seed values of the pixel. Yo, these people know they're doing too much now. I know. This needs to be stopped. This paper was not joking. This paper was hard. This needs to be stopped. Do you see how the level of things that they're asking you?
And you always thought this paper was easy. Hey, hey. Look at you now.
It was easy to do the other things, but when it comes to the logic part, it's
Mm-mm.
chowy because there's a lot. You see what they mean here by seed values? They mean this seeds array. If you go back here, remember that seeds array, right? Let me zoom in. So remember this array here. You see this one here?
Yeah.
They want you to sum up all the values, and then that sum, you use that as the seed for your random generator. That's what I'm saying. Why would you do that? So that's what they want. So let's do that first. So which is very annoying, but let's do it. Yeah,
Oh,
yeah, that's what they want. So pixels rc dot seeds, right? And remember, you need to start at 0. You start at 0 first, then go to 1, then go to 2, then go to 3, then go to 4, because there's 5 of them. So I'm going to say unsigned short sum is equals to this, right? Then plus, I don't want to do a loop. You could also do a loop here. You see how what I mean by this thing was chowing. I thought I had this thing though. It would just it's just good everywhere. And to know they're preparing you for the worst. Three, four. Because there's five elements, right? So we have that sum. Then you use that sum as a seed. So I'm gonna say S rand seed is sum. You use that value to seed the random generator for every pixel. So hence it's within the for loop for columns. That's why I'm saying these people now. I've never seen this before. It's the first time seeing this on this question paper. They were on steroids. And then they said, I don't know what they said draw the pixel. What do you draw exactly? Let me see a stochastic. So there's the pixel, right? So what do you draw exactly? That's what color? Oh, okay. By draw the pixel. Hmm. I see now. These people want you to think. So by draw the pixel, they just mean leave it as it is. So you actually won't do anything here. So you do nothing here. The only part where you do something is when it's not the case. Because remember we read from the file. Those were the pixels from the file. So that means leave them as they are. Else set it to a black image, right? So otherwise set it to a black pixel. So I need to set it to a black pixel. How do I set it to a black pixel? First of all, I need to get the pixel, which is really annoying. So yeah, I need to say UJ pixel, pixel, obj image. Um, okay, this is wrong. You see this? This is wrong. I totally forgot. I'm no longer inside EJ image. I need to always call it via that object. So this needs to, okay, this needs to change a lot. So I need to say obj image dot get pixel with a specific row and column. Yeah, this is how I was supposed to write it. Remember, you're outside of the class, so and you need to use accessors now. Then do that, then do that. So we sum them up. You could use a for loop if you want this part. That's up to you. I'm not gonna confuse you and have three for loops now. Then you'll be like, yo, hey, let me just leave com sci. I'll see it next year. I don't want you to have that that in your mindset. So I'm gonna get the pixel first, and then I need to set the pixel. But remember that pixel, when I put it back, I need to make sure I change the red and all the color components to 0. So pixel dot green is equals to 0. Pixel dot blue is equals to 0. But that's black. Black is when all of them are at their minimum or their lowest, which is 0. Then I set the pixel, obj image dot set pixel at a specific row and column, set it to be that pixel. So when they said draw, right, that means you actually do nothing there. The main part is this part. When it's greater, basically when it's greater than the chance, that's when you do that. You set it to black. And then you're done. That's pretty much the logic. Yeah, that's everything. The seed value must be the sum of yeah, we did everything. So let's try to render this image and see if we get the output. But I'm sure we're gonna have quite a lot of errors. Let's build it. Mm, yeah, you see, Dr. Strong, he expects you to name things the way he wants you to name it. You see, he expects you to have named it int red at his lecturers, man. You see, I've named it red. He expects you to name it int red. If I was to change to int red, I would have to go to every single place where I use the red. So I'm not gonna do that. I'll change his main. I think that's the best way to do it. You must change where all those small things like this because now you can't be changing the whole file. You see how many files are there? That's a lot to change, man. I can't be changing all those things. And then build. Didn't I include the head of? Oh yeah, the override keyword shouldn't be there. Like I said, don't put the override keyword in your implementation file. Um, what did I do wrong here? Const. What does this say? Passing const. Oh, UJ is this. C++ is very peaky. Sometimes it pisses me off. So it wants you to have your enforced, put a const on your enforced range function because it sees that your enforced range function doesn't have a const, which means that it has the probability to make permanent changes, whereas you're calling it in something that uses a const, which doesn't want any of those possibilities to be there. So I need to put that const. So I need to, even in the implementation file, since I've changed it there, so I need to append the const at the end here. Now what? Oh, min size. Spelling. So I was spelling it wrong this whole time. Oh, I didn't even notice. Uh, yes, incomplete type. Is this thing crazy or what? C++. I feel like C++ should be cancelled by Fate. It's not. Um. Okay. I've got to. Let me. Didn't I include it somewhere there? Let me include the string stream. Which part is this one now? Oh yeah, I needed to. And I must return. Remember, after summing up, it expects me to return a UJ image, so I must return myself. So return dereference this. You could you could return UJ image by reference. Up to you. You decide whatever way you wanna do it. So let me see if we do get some output, Nyan. Where ngani one? Oh, I see my error. I forgot to deallocate. Remember we instantiated that renderer, we didn't deallocate it. So life cycle management, I think that's where it's complaining. Life cycle management. The thing is, you never know. Then students send me that error. What's going on? Do you know what could be wrong? I do not know. I'm not a computer, guys. I'm not a psychic medium, whatever. I can't prophesy things. Like you see that number there, how would you know that there was an error somewhere in your code? You wouldn't know. Okay, I did deallocate. So somewhere, somehow. I think it's this whole constructed thing. It's this thing of the reading from the file or whatever, this constructed thing. Okay, it's fine. Let me comment that out, right? I think this is the file. This is the problem here. I think I need to find a way to call it inside my AG image. I think that's the problem. I'm not sure. Okay, clearly that's not the problem. Okay, let me run it via the terminal. Duh, 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 duh. If instructions are not clear or people didn't set the paper well, you get errors like this. This paper they didn't, if I'm being blunt, they didn't set it properly. They didn't. Things are all over the place. They didn't even double check. Does it make sense to call it the code to say tell students call this thing there? They didn't even check all those things. Uh, is clear, and then ls, and then G++ compile everything that ends in it but CPP, send it to main. I want to see, maybe it might show the actual error here. Wait, it doesn't show the error here. Well, how come it's not showing the error here? And then I'm gonna have a main.exe. Then to execute it, dot forward slash main.exe. Or maybe it will show the error when I run it. Yeah, there's no output. Something is definitely wrong. I don't know because I don't want to waste your time. I guess we'll try and figure it out because it did allocate everything properly. Let me see. I do take in those rows, right? Oh, I think I kind of get it. Let me initialize. Let me put back that code underscore rows is equals to rows underscore calls is equals to calls. Think that's possibly why it's complaining. I'm not sure. Let me build and run again. Okay, that's not it. And I do initialize it there. If it's underscore stochastic, it's equals to that. Where's the file? Yeah, we do read from the file. That's fine. There's everything. We do read from the file. Mm. Yeah, I think coding the file there is not, you see, the only problem is the way they've set the paper. That load dot from txt could be the cause of all of our problems, some way, somehow. Mm, not yet, CPP. So we do allocate, right, which is fine. Mm, and it should be called within the no args constructor. Let's try and do that. I don't see how that makes sense. So let's try and call that function the no args constructor. So load from txt, from which file? Init underscore large dot txt, right? Load from the txt. Mm, yeah, I did remove that line, and then this remains the way it is. Let's try and build and run. I doubt it's gonna work. I doubt it's gonna work. That's the thing. I don't know which exact part is causing this error. Because it seems like there's an error with, I think the error is, you see somewhere here, this. I think that's where the error is, right here. And that issue is caused with the file handling. We do read from the file, that's correct. The problem is the order and things like that. Yeah, and then this paper was something else. Mm, maybe it's this operate. Okay, maybe it's the operators. Let's see. So I'm gonna comment out that plus plus operate. Let's comment out that plus plus operate and see if that could be the issue. Clearly, that's not the issue. Assignment should be fine, but let's comment out and see. Or maybe it's the draw. Then build and run. Okay, assignment is fine. That's how you test. You just go into comment out certain lines of code and then test to see if you've commented out those lines, it runs. So draw method, I commented out, it still doesn't want to run. So yeah, okay. And you see, it expects you to create a set pixel. So we do create a set pixel. We do have that. We do have everything. Or maybe it's this. Let me try change this to unsigned short. To unsigned short. Could be the error. Don't know. Yeah, that's not the error, but let's just leave it as it is. So get pixel, which returns a pixel, then convert to that, and then obj, blah, blah, blah. Yeah, I clearly don't know what's the issue here. So, yeah, I don't know what's the issue. Mm, yeah, everything seems fine. I guess I'll try to decipher it or we'll decipher it together. I just go attend for now.
All right, I'll see you later.
Okay, sharp.
Sharp.